So a few introductory comments on the presentation. First, let me say that we have developed this as a comprehensive overview. Don't expect or try to remember all of this information. There are a ton of features available through this new installation, and no doubt there will be some that have no interest to some of our pilots. That's fine. You can use this equipment on many different levels. Aside from this presentation, we've also created a training syllabus that's tailored for both the basic VFR or advanced IFR pilot. And we've developed a sort of cheat sheet, a quick reference that will be in the cockpit to set things up with when you first sit down. Also, our checklists have been updated to include necessary checks and emergency procedures, and all of this has been reviewed with input from the 10 Blue Sky CFIs. And speaking of that, this presentation has been a collaborative effort, and I thank everyone who has gotten their hands dirty in its creation. I also want to say that this presentation uses images that have been clipped from various different areas. Some are from the manuals, and some are from related websites. So if you're looking for discrepancies, you will find them. Please just look at the big picture, and if you have questions, I'm going to ask that you just jot them down and ask when we have a chance later. The presentation should give you a solid understanding of the functions and operation of most of our new equipment. It's not going to make you an expert. Like any new equipment, it's also going to require some self-study and some time just poking around and playing with it. All the manuals you'll need are on the website, and you may have already seen that the manual for the G3X is 440 pages. Think of it as a reference guide. And if you want to take a deep dive on something, it's there. But don't feel like you need to read every single word. Like everything, there are tons of videos available online, and we've come up with a list also of links that we think will be useful. The club's going to have access to a GPU, so you don't have to burn tack time familiarizing yourself with this. But of course, you can't get the full picture without flying. So more specifically, this presentation will cover how the magic works, what it looks like and means, what it can do for you, and how to use it. What we will not cover is minutia. There's a lot of that, and this is not to say that it's trivial. I'm just saying that it's too much to cover. We're not going to get too far into the weeds with things like VNav or instrument approaches. Another thing that's important to understand about the G3X Touch is this. It was first developed for the experimental home-built market and then the certified market. That's us. It's unusual in that it has its own GPS and can be configured with other behind-the-panel avionics, radios, transponder, autopilot, and such. Then its touch panel can be used as a control for all that stuff. We're not going to be operating it like that. We have panel-mounted radios, navigator, transponder, so you won't have to learn that functionality. If you continue to do things the way you're used to, there'll be absolutely no confusion. How do you switch to a new frequency? You go to the radio and change it, right? Same with the volume, same with the transponder, same with the autopilot. So I just wanted to point that out. This potential functionality exists on the G3X, but just ignore it and think of it simply as a display. If what I just said doesn't make sense, I think it will within a few slides. I'm convinced that you're going to find the entire system to be intuitive. You don't need to learn every single capability to fly this thing. We've developed 2 curriculums to show you everything you need to know for both VFR and IFR, and it'll be tailored to your needs. In short, I'll be very surprised if every single member is not ecstatic with this upgrade. One thing that will definitely help the learning curve is if you bone up on your GTN 650 skills. The new 650XI is basically the same, but to make absolutely sure that you're seeing any small differences that may exist, you can go to the App Store and download the new XI simulator. So, this is the layout of our new panel with our existing transponder. The panel itself is gray, and these 3 additions will be the focus of our presentation. The G3X Touch in the center is our flight display with a whole slew of information on usability that we've never had before. The G5 to its left will function continuously and serve as a standby backup PFD with automatic reversion. And the GFC500, a top-notch autopilot and flight director which can capture pre-selected altitudes. It can climb or descend at the airspeed of your choice. And for the IFR pilots, it can fly a coupled approach down to 200 feet AGL. We've also upgraded our navigator, now the GTN650Xi, with faster and smoother processing. But most importantly, it's the brains behind Garmin's new SmartGlide. And finally, a new number 2 Navcom and new audio panel. We will take a look at SmartGlide, but otherwise, these last three upgrades, the GTN, the audio panel, and the radio, are not the subject of tonight's presentation. Most members already have some familiarity with the GTN 650, and the radio and audio panel are pretty self-explanatory. The manuals for these items are also on the website. So, this slide is my kindergartner's view of the innards, how this thing works. It's not critical that you commit this to memory. In fact, we debated whether or not these two slides should even be included in the presentation. But if you recall your private pilot check ride, you were responsible for being able to describe the function of the gyros. Now our gyros are gone, so I think this information may help in understanding what might happen if a component were to fail. Starting at the top, we have a new instrument called a magnetometer. It measures the magnetic field and, using its own internal database, applies the variation to derive magnetic courses and headings. We also have a new OAT gauge with digital output. We still have our same old pedostatic system, but its information is now digitized. So what's always been purely mechanical in the past is now being crunched digitally by the air data computer. To the left of the ADC, we see the AHRS, Attitude Heading Reference System, an ingenious device with very precise inertial sensors. Same concept as what's inside an iPad, but better. So again, what we've always seen with our beloved mechanical gyros is now all solid-state digital. No more caging the gyro, no more resetting the DG, no more tapping the glass to free a sticking needle. Now moving down, you can see that the AHRS collects all this data and feeds it to the G3X display. New engine sensors send their digits to the engine instrument system, which is displayed on the left part of the G3X screen, giving us a more accurate display with better fuel functions and leaning assistance. And finally, back up to the top left, all GPS data flows from the new GTN navigator to the G3X. The G5 standby PFD is a separate system that works almost exactly the same as what we saw with the G3X, except here the G5 has its own separate internal AHRS. Now, if either or both of the two G3X brains, that is the ADC and the AHRS, fails, this redundant critical data will flow from the G5. The G3X would continue to function normally. You would see some failure and reversion messages, but all functions of the G3X would continue normally, as would the autopilot, with no downgrade in navigation or flight capability. Now think about that for a second. With the old instrumentation, if you lost your attitude indicator or your HSI in instrument conditions, you'd be in a world of hurt. Not now. In fact, even if the G3X fails completely, the G5 will be your PFD and the autopilot will still function normally. And in a total electrical failure, this thing has a 4-hour internal battery. But of course, you'd be hand flying. And this shows you the functions of the G5, our standby PFD. It's required by the FAA for IFR operations. This mini PFD will look something like this all the time, whether the G3X has failed or not. So that, in a very small nutshell, is what we have and the cliff notes of how it works. Now let's take a look at some features. First, a quick look at the control knobs on the bottom of the unit. 2 concentric knobs on either side, we're used to those. They can have different functions, but you don't need to remember what those functions are because the unit tells you with a little legend right above the knob. Now, as I mentioned, this came from the experimental market. It actually has its own GPS buried in there somewhere, but it's VFR only. Ours, as you know, is WAAS and a fully capable IFR machine. Because of that, we will always be using the GTN for any navigational functions. And that brings me to what I want to say about this image. The Direct To button will only be used if the GTN has failed. And if you need nearest information, get it from the GTN. This nearest button will work similarly to the GTN, but if you needed or wanted to use it for any sort of navigation, like to go to a nearest airport or VOR, it won't work. So my suggestion is just get in the habit of using the GTN. The reason that these won't work for navigating is obvious. There can only be one navigation source at a time, and the GTN is our default navigator. In fact, if you remember nothing else from this presentation, remember that. The GTN is your navigator, not the G3X. The menu and back buttons are for navigating through the menus, and they definitely will be used. You'll see an example of that shortly, but let's take a deeper dive into the G3X display first. So here we see our old familiar 6-pack display, which is all self-explanatory, except I want to point out a few things. Our selected altitude will be displayed here. We have an annunciator here with white advisory messages, amber caution, and red warning messages. Our ground speed will be displayed, and our true airspeed also. Now let's take a look at the tapes view, which offers a fair bit more information in a different look. This is a common layout industry-wide for glass panels. If you've never flown with tapes, it takes a little getting used to, but believe me, it doesn't take long. And you've got more information available to you here. We'll just go clockwise around the screen and take a look at some of the features. The data bar is visible with round dials too and is configurable. It'll have all the fields that you're used to seeing: track, direct track, or desired track rather, estimated time en route, waypoint, etc. It also has the button on the far right, which is used to switch between the full screen and the split screen, where the MFD shows on the right side. We'll see that shortly. The altimeter is displayed on a moving map with a rolling barrel. You can see that we're at 5,000 feet, and at the top you can see the selected altitude of 4,000. The VSI also displayed as a tape. The Colesman window. The turn coordinator is split in two with the ball in the center of the screen and the bank on top of the HSI. The tick marks indicate standard rate and half standard rate turns. The HSI, the heading bug, and its numeric value. The wind vector, now that's a nice new feature. The ground speed. We'll have V-speeds displayed on the tape, and finally the airspeed indicator, again in a tape display with a rolling barrel. This will also display white arc, yellow arc, and red lines. Tapes view has the additional ability to display insets. Here you can see two insets in the lower left and lower right of the screen. The inset options are map, traffic, flight plan, nearest airports, and G-meter. And both tapes and round dials have the ability to show synthetic vision. Synthetic vision is a sort of overlay that uses the terrain and obstacle databases to create a forward-looking display of the terrain, including lakes and obstacles. But the really nice thing about it is that it provides all these other features. So we're going to touch on some of the symbology that comes with synthetic vision. If you don't remember each and every one of these things, don't worry. In a short period, it'll all be obvious. Here's the zero pitch line, which is not necessarily your flight path. This is the horizon. You can see here on the left side that zero pitch takes you into the mountain. It's also the baseline for the pitch ladder, which has 2.5-degree increments up and down. The flight path marker shows your trajectory where your present path will take you. Pathways is a Garmin feature that will show you a path to get where you've told the flight director that you want to go. I've never seen such a gizmo myself, and I really wonder how useful it is, but we spent some time with one of the install pilots up in Plymouth, and he likes it pretty well. We plan to leave it turned off to begin with, but you'll have the ability to use it if you want. Synthetic vision also displays airport signs that will pop up when you're close by, and it shows traffic with a color coding based on threat, runways, and there's also a sort of ground proximity warning system that will alert you to terrain and obstacles with a flag that works in conjunction with an oral alert. For example, caution, terrain, followed by terrain, pull up. So here is the split screen with the MFD on the right. When you touch the toggle in the top right corner, the right half of your screen displays the multifunction display, the MFD, and gives you access to a whole bunch more information. At the bottom, right under this sectional chart, you can see the menu of what's available. The knobs can have different functions, but if you're ever unsure of what they do, there's that little Q that I mentioned. This Q changes with the function. Here you can see it's zoom on the inner knob and switch page on the outer knob. That's to scroll through the pages that are listed horizontally there. Very intuitive. So now we're going to move on to the autopilot. Not all of our members are familiar with advanced autopilots, and in particular flight directors. This is the single most expensive piece of hardware in this package. It's a sophisticated system with advanced functions, but it is simple to use and understand. Whether or not you use it, it's important to understand what it is. The autopilot and flight director are two different features controlled from the same panel, the AFCS panel. The flight director is the brains and the autopilot is the muscle. The flight director drives the V-bars or command bars, which give you visual guidance where to fly. You control it with the AFCS panel, and by engaging the autopilot, you're telling the servo motors to move the control surfaces and make the airplane follow the flight director. Press the autopilot button in the middle to engage it. Now let's take a look at the AFCS mode control panel. It's got a lot of similarities to the Diamonds panel. This is where you tell the flight director that what you want the plane to do, and where you engage the autopilot to do it. So looking at each actual button here, that YD button in the center means yaw damper, and we don't have one because we don't need one. Every other button up here is a momentary action on-off switch, push to turn on, push to turn off, except these two. The flight director button turns on the flight director, and if you were to push it again, you could turn it off. But if you had also turned on the autopilot, then you couldn't turn off just the flight director. Remember, the autopilot is the muscle and it needs the brains of the flight director to function. And the LVL button in blue, that is designed for use when disoriented. It can be used at any time, regardless of whether the autopilot, flight director, or nothing is engaged. This button instantly engages the autopilot and flight director and commands 0 roll and 0 pitch. To get out of level mode is easy. Just engage another mode or disconnect the autopilot. And just like you'd expect, there's an autopilot disconnect button on the yoke. Push it once, the autopilot disengages and an oral alert sounds. Push it again and the oral alert stops. Click, click, your controls. Now, looking at the left third of the panel, you see that it contains lateral modes and the right third of the panel contains vertical modes. A knob on each side for selecting a new altitude or heading or track. And by the way, pushing either one of those knobs will sync your present altitude or heading. And additionally, on the right side, you see a wheel to roll up or down your vertical speed command or your airspeed command. So for example, if you were descending at 500 feet per minute and you wanted to hurry down at 800 feet per minute, you'd put your thumb on the wheel and push up, rolling it forward 3 clicks. Think of it like the elevator trim. Roll it forward, nose down. And the same logic applies in indicated airspeed mode. Finally, I just wanted to point out that this one button, approach, in the lateral section is kind of a hybrid selection because it can be both a lateral mode and a vertical mode. This autopilot is fully approach capable, and while tracking a lateral course, it can capture a glide slope or glide path and follow it down to minimums. There is an autopilot limitation here. It must be off by 200 feet AGL. Now let's take a look at the flight director command bars, your visual cues. Now I want to say again to keep in mind that the plane is still just a plane. It can be flown with or without the flight director, and knowing when to turn the autopilot off is just as important as when to turn it on. It's just a button push away. Right smack in the middle of the display on your attitude indicator, you'll see the yellow symbol for the nose of the airplane. And those two yellow lines on the edges symbolize the wings. They move together, hopefully. They're always visible. It's part of the attitude indicator. Now, when you turn on the flight director, the pink chevron appears. These are the command bars, or V-bars, or bat wings. Garmin has a visual differentiation when you're using the flight director only, or when you're using both the flight director and the autopilot. So here you can see the command bars appear hollow, meaning the flight director is on and the autopilot is off, the plane's being hand flown. Once the autopilot has been selected on, they'll appear solid. When it's being used, the flight director, as the name implies, directs the flight. The direction is displayed through the command bars. If you tuck the airplane inside that pink chevron and keep it there, it will direct you where to fly, both laterally and vertically. The convenience here is that it eases your instrument scan and relieves you of the requirement to refer to the other lateral and vertical cues. Just follow the bars. It gets its information from the selections that you make on the panel. So for example, in level flight, if you selected vertical speed mode up 500 feet per minute, the command bars would rise up above your airplane symbol and you would raise the nose to tuck it inside the command bars. And for a moment, let's assume that you were in heading mode. If you then moved your bug to the right of the nose, the flight director would command a roll right. Now let's take a look at the status box, which displays your autopilot and flight director modes. This status box, nicknamed the scoreboard, is very important to understand and to include in your scan. Whenever you make a change with the AFCS mode control panel, you should verify that you got what you asked for by checking the scoreboard. You could think of it this way. You make a selection on the AFCS panel, that's the meal that you ordered from the waiter. You look at the scoreboard and verify that that's what he actually brings to your table. We don't have a yaw damper, so we won't see that. There's a logic to the enunciation where green is active or engaged and white means armed. And the final slide of the autopilot just shows you that the status box or scoreboard layout, like the AFCS panel, also has a logic. The box on the far left enunciates the engagement status of the autopilot. In the middle, you have your lateral modes enunciated, and then on the right side, any vertical mode would be enunciated. So that's the very quick and dirty on the basics of our autopilot. Obviously, there's more to it, and the manual is actually part of the G3X manual. The chapter is labeled AFCS. But just so you know, the chapter has frequent references to touchscreen operation also, not just the mode control panel that we've been looking at. So now we're going to try to explain some of the specifics on what you might see and how you might use some of the magic on an actual flight. At the end of the day, it's still just an airplane, right? You push forward, the houses get bigger, you pull back, the houses get smaller. But the gee-whiz stuff is not only helpful and useful, when it's properly understood, it's also a significant safety enhancer. So, starting your day with a cold, dark airplane, you flick on the master switch, and the G3X and G5 will come to life. They're both powered by the primary bus. So you'll see something like this. Things will quickly start changing as the digital data is received. AHRS will need to align and certain components will initialize. You'll also see the database check. The entire process should take no more than a minute. The rest of our avionics installation, the navigator, the radio panel, and the radio, is all on the avionics bus. So that won't energize until you've started the engine and turned on the avionics master. Also, just as an aside, whenever you see a red X, obviously it has failed. There's no more insidious, creeping, slow vacuum failures that can be deadly, and no more sticking needles. And again, remember, we've got that backup, the beautiful G5. So here's our display in full screen mode. Again, remember what I said at the beginning about some of these images. They're not all perfect. We're obviously not in flight yet. So remember the name of this thing, the G3X Touch. That's because there's touch functionality built into almost every square centimeter of this screen. And by the way, you've got to touch it with a bare finger. Gloves won't work. On the left-hand side, you see the engine instrument system. The EIS strip on the left has all the info you need, but if you simply touch it like this, a dedicated engine page pops up. So now here you can see cylinder head temperatures, EGTs, and fuel info. Additionally, you can see engine hours, that's takt time. So this is where what you're going to do right now, check the takt time for the Blue Book. And on the right is total hours, that's Hobbs. You can also see two more pages for electrical system and fuel calculator. What's the very first thing you do after the engine starts? Eyes on the oil pressure, right? Hopefully the RPM is not 2420. And you're going to want to check your desired instrument configuration, tapes or round dials, and whether or not you're going to use synthetic vision. This short video shows how you would switch between tapes and round dials.
G3X Touch has the ability to display round gauges along with your standard new style tapes. To gain that functionality, we're going to select menu twice. Menu, menu. We will go to Setup, PFD, and select our PFD presentation. We have the choice between tapes and round gauges. Round gauges will show us our standard 6-pack that you would expect to see in an older aircraft.
I mentioned before that tapes view has the benefit of displaying insets. Here's how.
We're going to look into the insights on our Garmin G3X Touch display. To enable those insights, we're going to select Menu, and we're going to go to our inset windows here. They're both off right now. We're going to select what we want to view. So we want to view our movie map, and then we also want to view our flight plan page. From that point, to get back to our full screen PFD, we're going to select Full. As you can see, we have our map page and our flight plan page. Now, these two insets do some other features. They sit there and act as shortcuts to other functions on our G3X Touch display. If we select the map page, it's going to pop up a map for us, easier for the pilot to view. From this map page, we can use our concentric knob here and go over to waypoint. From waypoint, that is going to show us where we are. So November 51 is where we're at. Here's our runway information. We can select any of the runways at the airport. We can select our frequencies, anything from ATIS to flight service to approach, departure frequency, along with our IFR approach charts for that airport. Also, in this window here, you can zoom in. There's no taxi diagram at your airport.
So the traditional 6-pack view doesn't have that functionality, but both the tapes and the round dial views offer synthetic vision, which is quite an enhancement. This short video shows you how you would select synthetic vision on the PFD. If for some reason you didn't want it, you could also deselect it here.
In this scenario, super easy to turn on the synthetic vision in the G3X Touch. We're going to select Menu and then Menu once again. We're going to go into our setup. We're going to select PFD, and we're going to scroll all the way to the bottom and select our synthetic vision. Synthetic vision has a few other features like airport signs, flight plan markers, pathways.
And I just want to reiterate that we will have a cheat sheet in the cockpit for quick access to some of these basic changes that you may want to make. Don't feel like you have to memorize all this stuff here and now. So now that we have our cockpit set up the way we want it, we'll taxi out. Safe Taxi is a Garmin feature visible on either a map page or a waypoint page on the MFD in split screen. For anybody who's ever been confused taxiing at an unfamiliar airport, this will be a big help. Everything is labeled, the taxiways, the runways, ramps, tower, even the hotspots have an explanation, so you can see the big red circle there contains the label complex intersection. Pretty sweet. Now, this top image is obviously on approach, but synthetic vision would give you a similar view taxiing into position for takeoff. This could be a useful tool for either the VFR pilot or the IFR pilot in low visibility. For the VFR guy who is hand flying, you might climb to altitude and then turn the autopilot on. The flight director command bars would appear, and then you'd sync your heading and select heading mode and altitude mode, and then maybe direct to on the GTN and click nav on the autopilot. And of course, you would verify these selections on the scoreboard. For an IFR pilot blasting off into a low ceiling, it could be helpful to use the flight director. You could press the toga button. It's got to be done on the ground, and the flight director would command wings level and a predetermined pitch up. On the scoreboard, you'll see TO. After reaching a safe altitude, you could select a heading and an airspeed climb with altitude capture armed. Again, you would verify these selections on the scoreboard. There's a limitation on the use of the autopilot. That's 800 feet AGL on takeoff. So, upon reaching cruise altitude, you want to lean the engine. There's absolutely nothing wrong with doing it the way you've been doing it, lean till rough, rich till smooth. But our new instrumentation offers another tool. Here's the procedure using lean assist. Now, what you don't see at the beginning of this video is where the operator simply touches the EIS box, like we did to check the takt time. That brings up the engine info page, which we're looking at now.
I can use the lean assist function to help me detect the peak EGT, and it detects the peak fuel flow on the fuel calculator page. The peak fuel flow allows me to operate rich or lean a peak depending on what I'm trying to do.
The fuel calculator can be used to compute fuel burn along the way and to alert you to reserve and destination fuel status. Now, let's take a look at our charts, which we might be using during cruise. Blue Sky has a subscription that will allow us to display current charts, both en route and approach. We've seen the airport diagram already under Smart Taxi, and we also had a slide with a VFR sectional. Here's an IFR low chart, and here's an instrument approach procedure. Now, I'm going to take a slight diversion from our hypothetical flight and talk about some more of the built-in safety features. This one is called ESP, Electronic Stability Protection. ESP is a form of envelope protection designed to keep the airplane operating within safe parameters. It automatically arms above 500 feet AGL and disarms below 200 feet. These chevrons indicate that it has engaged in the pitch axis. It has roll protection and airspeed protection also. With the autopilot on, if for some reason you were to get below 65 knots, three things would happen. The autopilot would lower the nose, you would get a min speed message, and you would hear an oral alert, airspeed. With the autopilot off, you'd have similar alerts, and the ESP would provide proportional stick forces to lower the nose. It works for high speed too. And as I mentioned, both bank and pitch. It provides resistance in the form of stick forces to get you to do the right thing. It can be disabled for maneuvers, stalls, steep turns, etc., but will automatically be re-enabled with a power cycle. There is also assistance for unusual attitude recovery. This is a separate system from the ESP. These red chevrons are permanent. They're always visible 50 degrees above the horizon and 30 degrees below. And if a pilot were to exceed preset parameters, the system will also declutter the screen, which is a sort of forced focus. And this last safety feature is Garmin's SmartGlide. This is not part of the G3X, but it is part of our new installation. The system is driven by the new GTN navigator and constantly evaluates your position and distance from nearest airports. Should you lose power, flip the guard and push the switch. This is what you get. It evaluates airports that are within glide range and that meet preset criteria for runway length. It looks at winds and weather if that's available. Then, provided there is such an airport, it gives you options with a direct to routing, turns on the autopilot, and pitches to best glide. It also provides a prompt to squawk Mayday and gives you information on the runway length and your altitude AGL. If this is an off-airport landing, SmartGlide gives you audible AGL alerts. And finally, bear in mind that this is not Garmin's emergency autoland, which you may have read about. About 2 miles from the airport, it alerts you orally and visually when it's time to start flying again. I think it's fair to say that this will reduce the task load significantly in such an emergency. So now back to our normal flight. Airport signs is a feature of synthetic vision. They appear when you're about 15 miles from an airport. They are initially shown with just a small flag, and as you get closer, the actual identifier appears like we see here. And as you get closer yet, the actual runways appear. Initially, they're gray, and when you're within 45 degrees of the runway course, they appear in white. And if you have an approach to that runway selected, it appears brighter, and as you get closer yet, more information appears. The numbers, the center line, so on. At approximately 500 feet above the airport elevation, you would hear 500 enunciated. For landing, the autopilot must be off by 200 feet AGL. That's the limitation. And here's the synthetic vision view of the runway. If you were to need to go around, you could hit the toga switch with your thumb as you push in the throttle. This will engage the flight director and command a wings level and pitch up attitude. The scoreboard would say GA, GA, and if you had preset an altitude, that would be armed to level you off there. And if you had an instrument approach loaded, it would activate that part of the procedure in the navigator. And again, like we saw taxiing out, the safe taxi depiction of the airport will be very useful at an unfamiliar airport, and especially at confusing intersections. If the MFD is selected and map page is up, this should pop up automatically when you're on the ground. So that about covers what I've prepared. We've taken a look at how this stuff works and communicates, what it looks like, and what it does for you, the pilot, and the basics of how you use it. As I said, there's a lot more to this, and it will be incumbent on you to study yourselves. The Skylane page on the website has been updated, and the manuals are all available for download there. We've also put together a list of suggested videos with links. I would strongly suggest that when you do get in the cockpit to play around with the GPU connected, you try touching everything on the screen to see what pops up. Just play with it. As I mentioned, with the input of the other CFIs in the club, we've also developed a syllabus for hands-on training for both VFR and IFR. So, happy to take questions. I can't guarantee that we'll have all the answers, but we'll certainly try.